This is a video to explain the questions at the end of the infrared spectroscopy booklet from your class notes. There's 4 questions and I'll work through them one by one. If you just check off your answers, anything you don't understand that I'm talking about, if you maybe come and see me and I will explain. So let's have a look at the first one. So that's just a table, by the way, sorry, of bond frequency absorbances that I will be using as I go through this. It's the one out of your notes, so you'll have it at hand. So the question, first of all, is how could you use infrared spec to tell the difference between a sample of butanol and butanoic acid? And it specifically says, and this is where a lot of students drop marks, it specifically says that you need to make reference to peaks which are present and peaks which are absent, using specific absorption values. So you must go back to your table and you must talk about specific actual frequencies which are absorbed. You can't just talk about the bonds. Okay, so what is this examiner after here? Well, if we just draw out very quickly what we've got butanoic acid, 1, 2, 3, 4, of course, CO double bond and a COH bond, and we have got butan 1-ol, which is still 4 carbons, and we have an OH. So this is very simple. On both of them you're going to have an OH absorbance. Okay. On the carboxylic acid one you're going to have that OH absorbance of between 2,500 and 3,000. Okay, so that's going to be between 2,500 and 300, which is, you would quote that to the examiner that it's an OH at that range. And in the alcohol you're going to have also an OH absorbance, but it's going to be 3,2 to 3,5. So this is going to be 3,2 roughly to 3,350. It might change depending on what table you get, but you get the picture. Okay. Now the additional thing that you need to make mention is that you're going to have a COO absorbance in my carboxylic acid group, which is sort of 1650 to 1850. So I think we have it 1630 to 1815 according to the tables there. So that's the kind of answer that you want to have. All the bonds identified and all the absorbances quoted. This time we thought we had a sample of ethanol. How would we use an infrared spec to verify if there are impurities in it? Well, very simply here, what you do is you get the trace of the pure ethanol, okay, and you locate that infrared spec trace of that. Then you run a trace of what you think is the impure ethanol, okay, and you obtain that trace. Now both of these should have all the same peaks. That's really important. Both of them should have all peaks the same. Okay, so whatever peaks are in, let's call this one X, whatever peaks are in X should also be in Y. But if there are impurities in it, then in the impure, or Y as I've just called it, you will have additional peaks. Now you don't know where they are or what they are, but all you need to say is that you will have more peaks in the impure sample, if there are impurities in it, but you will still have all of the peaks that were in the pure ethanol. So you just basically overlay the 2 traces on top of each other. Right, a pharmacologist thought that they had developed a new drug, totally new molecule. Okay, you've got to use IR spec to confirm whether they had or not. But basically what you do is you will run the spec, okay, you'll take this, you'll run the spec and you'll obtain the trace, and if it's a completely new molecule there will be no match on the database for that molecule, no match whatsoever if it is a completely new molecule. Finally, a student is making some propanoic acid by oxidizing propanol. How could they confirm that they're actually going to completion? So if we look at propanol, okay, so that is C2H5 CH2OH. That will first of all get oxidized to C2H5CHO, which is propanol, and it will then get oxidized to C2H5COH, which is your propanoic acid. Okay, so it's as if it's gone to completion. So completion would be gone to the carboxylic acid, and you've got to show that it's gone to completion. You've got to again make reference to peaks that are present, make reference to peaks that are absent, and talk about specific absorption values. Right, So we're going to start here off here with the peak that we will have will be the alcohol, which is roughly 3200 to 3500. Okay, now if it has gone to complete oxidation, excuse me, that OH alcohol peak will have gone, so it will now be absent. In fact, even if it's gone to mild oxidation to the aldehyde, that peak you would also mention has now gone. It's absent. Okay? Now, if it has only gone to partial oxidation, hasn't gone quite through to the carboxylic acid, you would make mention that you will now have a COO peak, but you will only have that. Okay, and that COO peak is around 1650 to about, I think, 1815 on the table from earlier. Okay, so that's if it's only gone to partial. If it's gone to complete oxidation, then you will have the COO peak at roughly 1650 to 1815. Okay, you will also have an OH, but that's an OH for an acid peak, which is a roughly 2500 to about 3000. That is present. Okay, and that is your answer. That's all the information that you need to have in there. Okay, so you talk about the original OH, which is from an alcohol, but the fact that that has disappeared in both, no matter what type of oxidation has gone, but if it's completely oxidized and there's none of that alcohol left whatsoever, that peak has disappeared. Okay, so that would indicate complete oxidation. You will find that you will have the COO peak at 1650 to 1815. Okay, and you will find that you will also have an OH peak now at 25 to about 3000. Okay, right, hope that all helps, guys. Okay, there are more past paper questions in your alcohols booklet, and there are more at the back of the notes as well. Thank you.